You know that feeling, right? You're stuck on a delayed train or your flight gets canceled because of some surprise mechanical issue. It's frustrating, it's expensive, and it just feels so reactive. But what if we could know with incredible accuracy that a specific part was about to fail before it actually did? Well, that's the promise of a really powerful new approach that combines real-time data with artificial intelligence. In this explainer, we're going to break down exactly how this tech works and find out if it can really make unexpected breakdowns a thing of the past. So, here's what we're going to cover. We'll start with the old, kind of flawed ways we used to fix things. Then, we'll dive into a much smarter strategy and meet the AI that's basically a digital mechanic. We're going to get into the most popular AI tools for the job, see which industries are already using them, and then wrap up by looking at what this all means for the future of maintenance. Okay, so to really get where we're going, we first have to understand the problem we're trying to solve. For decades, maintenance has really been dominated by two main philosophies. And honestly, both have some pretty serious drawbacks. On one hand, you have corrective maintenance. You probably know its motto: if it ain't broke, don't fix it. It seems simple and efficient, right? Well, that is until a critical part suddenly fails, leading to long, expensive, and totally unplanned chaos. On the other hand, you've got preventive maintenance. Its whole idea is to fix it before it's broken by replacing parts on a rigid schedule. And yeah, this definitely cuts down on surprise failures, but it can be incredibly wasteful. You're throwing out perfectly good parts that have months, maybe even years of life left in them, just because the calendar said so. So really, both are a gamble. One is betting on luck, and the other is just wasting money. Clearly, there has to be a better way. Instead of just guessing or waiting for a disaster to happen, what if we could act at the absolute perfect moment? This is where a much more intelligent strategy comes into play, one that's all about working smarter, not harder. And that strategy is called condition-based maintenance, or CBM. The idea behind it is, well, it's brilliant. Think of it like a doctor monitoring a patient's vital signs in real time. Instead of just a checkup every 6 months, the doctor gets an alert the second something looks off. CBM does the exact same thing for machines. It uses sensors to listen to the actual health of a part. And the goal here is surgical precision. Perform maintenance at the exact moment it's needed. Not a day too early, and definitely not a second too late. So how does this whole process work? It really boils down to four key stages. First up is data collection, where a ton of sensors are constantly gathering information, vibrations, temperatures, you name it. Think of it as the machine's heartbeat. Next, you've got data processing. This is where all that raw noise gets cleaned up to find the signals that actually matter. Then, in step 3, comes the magic, decision-making. This is where intelligent models analyze those signals to not only figure out what's wrong now, but to predict what's going to fail in the future. And finally, all that insight leads to action. A repair gets scheduled, an inspection is ordered, and a crisis is completely avoided. So, you're probably asking, what exactly is doing that decision-making in step 3? I mean, how can a system possibly make sense of all that sensor data? Well, this is where we introduce the brains behind the entire operation. It's artificial intelligence. AI and machine learning models are the engine that makes modern CBM possible. They can sift through millions of data points every single second from hundreds of sensors. We're talking a fire hose of information. Their real superpower is finding those super faint, almost invisible patterns that signal a future failure. These are patterns a human engineer could never, ever hope to spot. It's all about finding that one critical signal in the noise that can predict a breakdown weeks or even months in advance. So what kind of AI are we actually talking about here? Well, a really comprehensive review of the field found something fascinating. A whopping 77.5% of the models used are what are called black box models. Now, that just means they aren't programmed with a bunch of human-made rules. Instead, you feed them mountains of sensor data from both healthy and failed parts, and they literally teach themselves to spot the difference. In this world, the data itself becomes the instruction manual. Okay, so we know that data-driven black box models are the way to go, but that's a pretty big category. So let's get a little more specific and reveal the two AI techniques that have become the clear winners in this whole field. The source for this explainer, which is a massive systematic review, crunched the numbers from over 100 different studies to find the answer. And they found a very, very clear trend. Two techniques just kept coming out on top: artificial neural networks, or ANNs, and support vector machines, also known as SVMs. These are the real heavyweights in the world of predictive maintenance. And the numbers really tell the story here. Support vector machines and artificial neural networks are basically neck and neck in popularity. They are miles ahead of the next closest technique. So what this tells us is that when engineers need powerful, reliable tools for this job, they are overwhelmingly choosing one of these two models. But what do they actually do? Okay, so what makes these two models so special? Well, think of a support vector machine, an SVM, as a brilliant security guard. It's an expert at spotting trouble. It analyzes data and is fantastic at sorting it into two buckets. Everything's normal here, or, uh-oh, this looks like a known problem. It's great for anomaly detection, spotting that one thing that just doesn't belong. Now, artificial neural networks, or ANNs, they can do that too, but they also have something of a crystal ball. Because they're modeled after the human brain, they excel at prediction. They are the absolute go-to tool for calculating the remaining useful life of a part. So they don't just tell you something is wrong, they answer that billion-dollar question, exactly how much time do we have left before this thing fails? All right, so we've covered the what and the how. Now let's explore the where. Which parts of the huge transportation industry are actually putting this incredible technology to work?
Now, the findings we're about to look at, they're grounded in some really serious research. The systematic review that this explainer is based on analyzed a total of 143 different scientific papers, all focused specifically on using AI for this kind of maintenance in transportation.
And wow, the results are striking. Aerospace isn't just in the lead, it's lapping the competition. With almost 80 published studies, it has more than double the research of the automotive and railway sectors combined. So it's crystal clear that the aviation industry has embraced this technology way more aggressively than anyone else. The obvious question is, why?
And when you stop and think about it, it makes perfect sense. The focus in aerospace is on the most critical components you can imagine: jet engines and gas turbines. We're talking about multi-million-dollar pieces of equipment where an unexpected failure thousands of feet in the air is simply not an option. The stakes are literally life and death, which makes the predictive power of AI an absolute must-have.
So we've looked at the problem, the solution, the tools, and where they're being used. Let's wrap this all up by looking at the trajectory of this technology and what it really means for the future.
You know, this idea isn't brand new. The very first paper on it came out way back in 1991. For decades, it was kind of a niche academic field. But then, right around 2016, something changed. The research didn't just grow, it exploded. This timeline shows we're not on some gentle curve here, we are on a rocket ship. The recent breakthroughs in AI, plus cheaper sensors and massive computing power, have turned this from a theoretical idea into a practical revolution.
So let's boil this all down. What are the big takeaways? First, condition-based maintenance is just the smartest way to manage complex machines, period. Second, the workhorses making it all happen are data-driven AI models, especially SVMs and ANNs. Third, the aerospace industry is absolutely leading the charge, driven by that critical need for safety. And finally, you're going to want to keep an eye on the maritime and railway sectors. They are emerging as fields with just enormous potential for this technology to make a huge impact.
And all of this leaves us with one final, fascinating question to think about. We've seen the power and the potential here. So as this technology gets cheaper, gets more powerful, and spreads from aviation to our cars, our trains, and our ships, could we be entering an era where that frustrating, costly, and sometimes dangerous unexpected breakdown truly becomes a relic of the past?